So as we start our program this afternoon, I have the great pleasure of being able to introduce our Chancellor, Chancellor Randy Woodson, the 14th Chancellor at North Carolina State University. And I think, as many of you know, Randy Woodson was a plant molecular biologist and a gifted leader as a faculty member and now as an administrator. And a couple of weeks ago, he sent me a message about this conference and said he was really glad that the college in North Carolina is looking at this issue. He understands how important an issue water use and water management is. Randy Woodson also leads nationally as chair of the Association of Public and Land-Grant Universities. There is no greater champion of North Carolina State University. It's my honor to introduce Chancellor Randy Woodson.
Hello, everyone. You look so eager to learn. So we're talking about water. We got some outside, but I'm sure Dean Linton already told that joke and told me not to use it. So I apologize. But good afternoon. It's great to have you all at NC State. And as Dean Linton said, it's great for our College of Ag and Life Sciences to be providing this kind of leadership on what, without a doubt, is one of the most pressing global issues that will have an impact on everything from agriculture to the way cities are developed and the way countries behave toward one another. So there's nothing more important than water. And we have a broad representation today of people that are with us. There are representatives from academia, and we're glad to have our colleagues here, government agencies and industries of all sizes, and interested citizens who understand the importance of one of the grand challenges of society. So that cross-section speaks volumes toward the issues that we face as a world around water. And we hope that this conference will provide an opportunity for all of you to better understand and to discuss the issues that surround water, both in the U.S. and around the globe. And I'd certainly like to take a minute to thank all of our sponsors. I've been watching the names scroll across the screen. These are some of the most important. Apparently I'm not talking enough. Somebody's shutting me off. I just got here, for God's sake. Okay, anyway, so these are some of the most important partners for agriculture and for the College of Ag and Life Sciences in North Carolina, and tremendous leaders for our state. You know, as a land-grant university, and some of you might be from other land grants, you all know that as a university system, we're completely committed to both think at the deepest level, as we do through scholarship, and actually do, which is our motto at NC State, to think and do. And what I love about this place, and all land grants for that matter, is that we've always been about taking knowledge that comes out of our labs and our fields and and across our campus and put it into practical work. This afternoon, we'll review some of the research that's taking place here in the College of Ag and Life Sciences, and you'll hear from students and faculty that represent 9 academic departments and reflect a diversity of interest similar to what we see among the members of the audience today. So their research carries the promise of a world in which water is managed intelligently and sustainably, and in which we can grow and thrive without fear of scarcity in the most important of resources. I'm always impressed by the talent of our students. And I tell all of the people I interact with, it's a lot easier to be chancellor when you just put some students in front of a group. I found it's a lot easier to raise money, too, if you just put students in front of it, because our students are amazing. So while everything that you're talking about is hugely important today, it's so crucial that we take the information you derive from today's conference and actually put it to work. So I'm proud of the College of Ag and Life Sciences, Dean Linton and his colleagues and the faculty for organizing a conference like this that continues to keep the College of Ag and Life Sciences at NC State on the cutting edge of technology and the issues that we face around the globe. So thank you for being here. Thank you for coming to NC State, and good luck with the rest of your conference.
I'm now proud to share with you just a few examples of the leading research happening right here at North Carolina State University, where our faculty members are working to address the challenges of ensuring water security for the citizens of North Carolina and the world. We're going to have a number of presentations here, and my remarks on the text is that there's going to be some videos and there are going to be some live speakers. And it says each live speaker will introduce himself. I just want to assure you, that is, that those that are on the videos are also live. They just have chosen to make their presentation through the video medium. With that, we will start with the presentations.
I'm Joanne Burkholder. I'm the director of the Center for Applied Aquatic Ecology at North Carolina State University. For the past about 30 years, I have studied water quality problems from freshwaters to marine systems and trying to find good solutions to help take care of our waters better. This research is critically important to people of all ages in the state, although most folks don't realize it, but everybody depends on clean drinking water. It's vitally important to our health, and our research is designed to try to help safeguard especially drinking water supplies in the state.
This is an NCSU water quality profiler. Inside it you have a data logger that acquires the data from a water quality sonde, and it takes a reading at a discrete depth from about 10 meters to the surface. This is a YSI water quality sonde. This sensor here does dissolved oxygen. This does chlorophyll, phycocyanin, turbidity, and this is a pH electrode. Over here you have conductivity and a thermistor that does temperature. So there's all of these parameters are acquired by the profiler on the top of the platform. The importance for this is it helps the city of Raleigh know what type of water and the water quality that's going into their holding ponds at the E.M. Johnson water treatment plant. They have an estimation of how much algae is coming in, the dissolved oxygen, the pH, and all of these parameters help them make decisions on treatment and pre-treatment.
This organism is Anabanis sporoides. It is found in Falls Lake Reservoir along with other potentially toxic cyanobacteria. We're very interested in these organisms because they can cause human health issues. We can also alert the Raleigh water treatment plant of the presence of these organisms near the intake so that they can adjust where they bring in water to the plant to avoid the confounding effects of the algae.
We help to save the city of Raleigh a lot of money in terms of helping them figure out 24/7 how to economize, where the best place is for their intake, whether they need certain kinds of filters. This 24/7 safeguard monitoring really helps them make more cost-effective decisions. We also work in the triad and are helping the city of High Point. Between the two, we're helping safeguard drinking water supplies for about 750,000 people. I would really love to see more and more people understand and care about the need to protect drinking water. It used to be an issue in which people cared about fish health and were thinking more about the ecosystem and the animals and plants that live in it. Now it's vitally important to human health, all of us, and so I'd really like folks to understand that we all need to be the best stewards we can of these water supplies because people of all ages really could depend on them in their everyday living.
Good afternoon, I'm Laura Taylor, and I'm going to be speaking with you today about some work that we've done to estimate the economic benefits of improving water quality in North Carolina's lakes. And in particular, I'm going to be speaking about Falls Lake, which you see in the upper right-hand corner of this graphic. Falls Lake is in the Upper Neuse River Basin and is a particularly important reservoir for our region as it supplies drinking water for about 450,000 households in Raleigh, and provides a multitude of recreational opportunities for our residents in the Triangle as well as visitors to the area. Indeed, Falls Lake has about a little over 1.5 million visitations each year. However, the lake is impaired, does not meet federal water quality standards for its designated uses. This impairment is primarily due to nutrient loading, and which causes algal blooms and can be harmful to aquatic and terrestrial wildlife as well as to human health. In response, in 2010, the Department of Environmental Quality proposed a nutrient management strategy for the lake to improve it to fully restore the lake over a 25-year period. Substantial reductions in both nitrogen and phosphorus were going to be required in order to achieve that, and as part of the proposed rules, DEQ was compelled to conduct a cost and benefit analysis of the rules. And while they had the resources available to estimate the cost of implementing the program and some of the more easily measured benefits, such as the reduction in water treatment costs that the utilities would enjoy when intake water quality is improved, they didn't have the capability in-house to monetize the recreational benefits that Falls Lake provides North Carolina citizens, and in particularly how that value would increase when the water quality at the lake is improved and more visitors go to the lake and the recreational experience of visitors at the lake is enhanced. So North Carolina State led a multidisciplinary interinstitutional team to develop these economic benefit estimates. And you'll see in this graphic the results of that study where at the end of 10 years, when the lake is partially restored through phase 1 of the rule implementation, the economic benefits associated with increased recreation were relatively modest at about $50 million per year, and that's above and beyond the baseline value of recreation at the lake. But over 25 years, as the lake is fully restored, those benefits were expected to go as high as $200 million per year when the lake was fully restored. Up next, we've just received a grant from the US EPA to determine the economic benefits of improving streams and rivers in urbanized watersheds. Jordan Lake and Falls Lake cannot be fully restored without restoring the streams that carry the nutrients to the lake. We've just received this grant and we'll be starting on this work in the spring, so stay tuned, there'll be more to come. Thank you.
Grasslands are a very large percentage of the Earth's surface, and they're also very important in overall ecology in terms of the water cycle, especially absorbing rainfall that oftentimes comes in large doses here in North Carolina. If it hits pavement, obviously it runs off and it ends up being a flooding problem somewhere. If it hits overgrazed pasture or cropland that's been tilled, a lot of it will run off and cause flooding problems. But a grassland that's healthy has the ability to absorb a great deal of water during a short time and then release that slowly to the system as supposed to be natural part of the water cycle. So that's very important overall for all of us. One of the major breakthroughs in the management of these kinds of pastures is the improvements that have been made in electric fencing technology. So these fences that you see here have an electrical charge on them. It's basically sitting in the wire waiting for an animal to ground it out, and then the electricity will flow through them and into the ground. And so just their knowing that keeps them from touching fences. And so having them in a situation where they are confined to a small area allows us to take some control over what they eat and the impact that they have on the land, and then we can move them on to another spot and keep them off the spot they just grazed, again using this simple technology, and then that allows that area to rest and recover and for the grass to regrow and create more feed. One thing that's been of great interest in our workshops, and also it's kind of a tool to get people thinking and interested in the topic, is the dung beetle. There's the tunnelers, which are the most important ones, and those dig a tunnel about 12 to 18 inches below the cowpie. They take some feces and bury it down in that bottom of that tunnel, and then they lay their eggs there, and then that's where the larvae develop. So you can imagine that every dung beetle that's born, there's a tunnel that's left that's about the size of a pencil deep into the soil profile. And so that's one of the things that helps water infiltration during that heavy thunderstorm that we want to capture. We're in a pasture here next to a small stream that we've been studying for quite some time. This stream was a part of the pasture until about 15 years ago, at which time we fenced it out. We excluded the animals from being able to get into the water. There's been a number of studies that have been done. Some of the things we've learned from that is that it is important to fence the stream, but it's also important to manage the upland, the pasture part, and not let it get overgrazed and short so that you don't have a lot of runoff entering that stream area. Now this can improve the quality of the water, reduce nutrient loading that might be going down into the rivers, as well as make the farmer much more resilient against drought. The more of that rainfall that's absorbed from that one big thunderstorm during the summer can really help a farmer to live through a 2 or 3 week dry spell that may go after that. So really being able to better harvest and use the water on grassland farms is the long-term benefit.
Good afternoon. I'm Deanna Osmond, and I want to talk about how North Carolina Extension puts science into action. You all heard Dr. Reckow discuss the fish kills in the Neuse estuary and the resulting regulatory framework, which we've called the Neuse Rules. And it was from the Neuse Rules that the Neuse Education Team was born. This team's mission of North Carolina State University Extension Specialist and North Carolina Area Extension Agents was to provide science-based information and education to the agricultural and urban stakeholders in the Neuse River Basin. And I want to spend 2 minutes talking about some of our programming. Dr. Bill Hunt leads the Urban Stormwater Program from the Department of Bio and Ag Engineering. He, his colleagues, and graduate students developed some of the first urban stormwater practices in the state of North Carolina. And over time, those have spread across the state. But by taking that information developed from the applied research, he's developed a number of successful training programs where he provides over 8,000 hours of continuing education every year. His group also designs and implements practices such as the one you see in your lower left-hand corner of the screen. This is the largest urban constructed stormwater wetland in the entire southeast, and it's located in New Bern, which of course is in the Neuse Basin. Our first task in agriculture was to develop an agricultural nitrogen tracking tool that was required by the Neuse Rules. Soil Science led this effort with our interagency partners, and we used the best science available developed from NC State Soil Science and Bio and Ag Engineering. And what we've been able to document is that the agricultural community has not only met its 30% reduction goal, but actually exceeded it. We know, however, that these tools become static if you don't continue to do applied research. So we're working on riparian buffers, and we also do applied research in the area of nutrient management. Nutrient management is very exciting for us because it's a win-win for farmers. If we can optimize the nitrogen rates, we can maximize yields, reduce input cost, and reduce the nutrients running off from their fields. The Neuse Rules also required that we train anyone applying fertilizer to 50 acres or more in the Neuse River Basin. And so, along with the area agents and the extension agents in the Neuse Basin, in 1 year we trained over 2,000 farmers and green industry personnel. But of course, our training continues to this day. And so extension, working with stakeholders and using the best science available, is providing solutions to keep the water resources of North Carolina clean and functioning well. Thank you.
We are at the Pool Farm in eastern North Carolina, where we and the College of Agricultural and Life Sciences at North Carolina State are conducting cooperative research to test and improve a drainage water management practice that will improve crop yields and reduce the amount of nitrogen leaving the fields. In the past, we used flashboard risers, which are just boards put in rails on a riser structure, and those boards were very difficult to remove, and management of the structures became quite burdensome for the landowners and the producers in the area. So consequently, many of them were not properly managed.
Having been born and raised on a small family farm in eastern North Carolina, you quickly learn the importance of managing water as it relates to crop production. As a result, Dr. Muhammad Yusuf has worked with me along with Tim Appleboom in developing new technologies that will not only increase the profits for producers, but increase the crop yields and save the water quality, which is what we all wanted to achieve. This is a scale model of technology that's been developed in the Bio and Ag Engineering Department at North Carolina State to assist farmers in managing the control structures. It's a pretty simple design. It does away with the old flashboard riser system and puts in an automatic weir plate with a gate that is controlled by an electric actuator through a microprocessor here. It's fairly simple. It's all self-contained. A solar panel provides the power to a battery, and there's a microprocessor in here that makes decisions based on real-time data input from water table, height of the water in the ditches, the crop stage and growth. A producer would come out and simply select the crop to be grown. The microprocessor takes that information, runs through the program, gets in-field feedback, and makes a decision on whether to open the gate or close the gate at different times of the year.
As a result of long-term research in the College of Ag and Life Science at North Carolina State, we know the practices that are being investigated here on this field in farms here in eastern North Carolina will work. These controlled drainage practices, drainage water management, will reduce nitrogen losses to our streams and estuaries in the eastern part of the state by 30 to 50%, and will increase yield at the same time. Our research indicates that we can increase yields by 10% on average. These practices have been used and widely applied, and they've been successful where properly managed. The problem that we've had in getting them managed on a wide scale is the time and effort that's required by the farmer to move boards and to do the operations in a timely fashion. The technology that's been investigated now, that we have developed and is being evaluated and tested and put into practice now, will remove that barrier. And the potential for success as a result of that is enormous.
Good afternoon. I'm Tommy Carter with USDA and attached to the Crop Science Department here at NCSU for about the last 34 years. Today we've heard about a lot of wonderful programs at NC State to reduce, reuse, and generally manage water more efficiently as human beings. My talk today is to acquaint you with another aspect of water, teaching plants to manage water more efficiently. By teaching, I mean developing new crop plants that produce more crop for the drop. This is a pioneering area of research, and we're beginning to have some real success. It turns out that NCSU and the USDA Team Drought, as we are now called, are in the national forefront, leading a larger team of over 20 scientists covering multiple disciplines to develop drought-tolerant varieties. And so, for the next 2 minutes, you're going to get a whirlwind lesson in developing drought-tolerant soybeans. Drought is arguably the greatest limitation to soybean production in the USA. Looking at the long-term trends for U.S. yields, they're certainly going up over the last 30 years or so. August drought is dragging down our national yields, however, and that's those sunspots are where we have those dry August. Nothing else correlates to seed yield on a national level like dry August. Well, about 20 years ago, your crop scientists here at NCSU and USDA started thinking about how we might go about fixing that problem. Current breeding stocks were not adequate to build drought-tolerant soybeans. We really needed to bring a new bull to the soybean breeding herd for success. It turns out that Asia is the prime source of new soybean stock, the ancestral home of soybean, and also to many on-farm varieties that were developed by ancient Chinese farmers. This seemed to us a very particularly attractive idea since China has lots of deserts, and soybeans have been grown at the edges of these deserts for thousands of years. So do you think any of those soybean types might be drought tolerant? We actually traveled to China to learn about drought tolerant soybeans. It was very interesting, but at the end of our sojourn, they wouldn't give us any of their seed. Fortunately, the USDA has been quietly collecting soybeans from around the world for the past 40 years and preserving them in our germplasm collection. And these are preserved and ready for study and use, and so that's what we did. These Asian types look very different from our U.S. crop, but these are really diamonds in the rough. I call them different beans with better genes. And so here's our source to find maybe some new drought tolerance that we can use here in the U.S. And thanks to USDA for preserving these. So up till now, I've been talking about thinking globally, searching the world for drought-tolerant beans. Now I'm going to shift gears and talk about another principle, acting locally. We have a wonderful resource about 80 miles southwest of here, the Sandhills Research Station. This is a big sand pile, hundreds of acres, that grows good beans when you irrigate, but suffers severe drought when you don't. This is a soil pit on the station. This man is taller than me, but at the bottom of the pit, as with the top, it's all sand. So 2 weeks without rain in the summer, and plants really suffer. So here is that outdoor laboratory under drought. We brought our Asian cousins of the U.S. varieties to the station, and we grew out, thousands of them, and we grew them out, withheld irrigation, and looked to see what happened. We discovered something that we call the slow wilting trait. This is what most farmer varieties look like under stress. But some of these Asian types look like this. They're actually slow wilting, and you can see it pretty obviously in the field. The one on the right is now our new bull in the breeding herd to develop drought-tolerant soybean. New varieties are coming out. Our new release, our first drought-tolerant variety is called N8002. And it has, here is a picture of a field day. This is our extension specialist, Jim Dunphy, looking at this variety trial. And I think you can see where he's at. The plant looks pretty good in front there, or the soybeans that are wilting. And so this is our first success. We're building on that success now, but this is a pretty striking example of what we can do with genetics if we persevere. So I'd just like to conclude by saying thanks to the United Soybean Board and to the North Carolina soybean producers who have funded us heavily and for long term to get this job done. Thank you.
My work is a very fundamental approach to water conservation. My research interests are into understanding how enzymes work. Enzymes are a specific class of protein which carry chemical reactions. They are also called biocatalysts because they can trigger chemical reaction that wouldn't occur under normal condition, at room temperature and under normal pressure. So this protein able to bind substrate in specific location, and with the amino acid that compose them and interact with the ligand, they can carry out this reaction. The technique that we are using to understand this chemistry is crystallography. So in a crystallography experiment, we illuminate a sample, which is a crystal of protein, with either an X-ray or a neutron beam. The information that we collect from this diffraction experiment, the crystal diffract the X-rays or the neutrons, we can go back to the three-dimensional arrangement of the atoms in the protein. With this information, when we actually see how the thousands of atoms that compose the protein are arranged at the active site of the enzyme, we understand better how the enzyme function. And if we are able to understand at the atomic level how the enzyme carry out this very difficult chemistry, we can hope to maybe make some tweaks in order to gear the activity of the enzyme towards a different substrate, or to make the enzyme work at a different pH or at a different temperature, and that can be important in some industrial application. I work with a class of protein which is able to detoxify pollutants such as pesticide or insecticide. In a second class of enzyme that we are studying, we are interested in optimizing their efficiency so that less water is consumed in industrial processes. I'm hoping that the work we accomplished is one of the solutions towards water conservation and will complement the other approaches undertaken by colleagues in the college.
Afternoon, everyone. I'm Rich McLaughlin, and I'd like to talk to you about the exciting area of construction site stormwater. For more than 50 years, I prefer water that is clear, and that remains my goal and where my efforts still steer. People build things like houses, offices, and roads, but in the process, each storm erodes. Sediment plumes in our streams and our lakes. Are we doing things right or making mistakes? Sediment and turbidity are pollutants number one, impairing our waters and making them no fun. How big of a problem do we have when we build? This much sediment in streams means fish killed. When we looked at how well our practices protected, huge losses of sediment and turbidity we detected. Get to work on erosion, sediment, and turbidity so we can prevent aquatic habitat morbidity. In the lab, in the field, we tried many things. The things we found were pleasing, so hope ever springs. Spread the word to all the agencies involved. New practices adopted and problems are solved. Into manuals, drawings, and plans, these all go. The water much cleaner, our studies will show. Research is great, but spread the word we must. Don't let the practitioners be left in the dust. Workshops, lectures, hands-on training for all. Learn how to do it, then go build that big mall. There is a way to be successful around here. With ideas and funding, solutions appear. Students and colleagues all worked as a team. That's how it's possible to keep our streams clean. Can we continue to build without so much harm? No problem, our systems can work like a charm. These practices are now spreading and nationally too, but it's just another case of Wolfpack think and do. And now, I'd like to invite you to a 60-second workshop. Great, so this is a typical workshop for us. If it's a large enough group, we'll break them up and split them into teams. This is a case where the teams are actually competing to see who can reduce erosion the most in our erosion rainfall simulator. And we come back at the end of the workshop and look and see how much sediment they have in each bucket. In addition, we have, this is the area that's probably the highlight of the workshop, where we describe and show them how to clean up muddy water in a ditch line using a small amount of chemical. And as you can see, we simulate stormwater coming in from a construction site, very muddy, and then we watch as the water goes down through the ditch, and slowly it is cleared up. They take samples, they show it to each other, and there's always an aha moment at the end of this demonstration, and you can see how much cleaner the water is by the time we've done our treatment. Thank you.
The work that I do at State is working directly with fruit and vegetable growers in the area of fresh produce safety and production.
Normally I'm with growers or processors, so we're either at the farm trying to figure out some of the practices that they have and how they impact, for example, surface waters like this one, or if we're in the processing scenario or in a packing facility, what are the practices within each of those that may impact the microquality of those produce.
This pond represents kind of a typical North Carolina irrigation setup for our fruit and vegetable growers, using surface water from ponds, streams, rivers, or protected waters like wells or reservoirs that are less accessible.
At least in the southeastern United States, there's many regions in which surface water like this ones are the source for irrigation, and they're either in close proximity to housing or into other operations. So everything we put out is going to come back into those waters, and so we need to make sure that we're conscious enough of the quality or the water that we're putting out or any chemical that we're putting out, because then that's going to impact the quality and safety of the water that the growers use then for irrigation. That would then impact the quality and safety of our produce.
In sites like this, where we're sampling for microbes or kind of harborage sites where pathogens may be found, what we're looking for is transmission onto the crops that we're growing. So in the environment, if those pathogens exist, for example, an animal has come through an area and deposited a pathogen in their feces, we need to know what's the likelihood that that can get transmitted to a crop. Splashing, workers moving it, other animals tracking it into the field. We need to know what's the likelihood of that hazard actually posing a risk to the crop that they're growing.
When you have a surface water like that one, normally what growers do is that they will first have a step in which you filter some of the sediment. You're trying to remove the turbidity of the water so that then either it doesn't clog any of the emitters used in drip irrigation or through sprinkler irrigation, but then also if you're treating that water with some kind of disinfectant like chlorine, then that chlorine would react more with the microbes and the water itself and not with the actual particles coming from surface waters. It makes a lot of sense, especially when you cannot control what type of animals are around your pond or what kind of inputs are coming into your pond that then are used for irrigation.
I really hope that the work that we're doing here can demonstrate to growers where risks exist, and then most importantly, how to mitigate those risks so that the crops that they produce can be as healthy and high quality as possible.
Do you all want to waste water irrigating your lawn? Neither do I. I'm Grady Miller. I'm going to spend the next several minutes talking to you about some of our work which is designed to improve water conservation in the landscape. So a question you may ask yourself is, how much water does turfgrass use? The truth is, if water is available, it will use appreciable water. But the reality it is we have greater factors that influence water use than the turfgrass itself. Many of our environmental factors are much more important. So the argument against cool season grass like tall fescue versus a warm season grass is not as important as it has probably been made out to be. So these environmental factors listed on the slide can be very important for us to monitor water use and also predict how much water North Carolina turfgrasses need. So using historical data and other data points, we've made prediction equations across the state to actually give us an idea of what the gross irrigation requirements would be for turfgrasses. So you may ask yourself, why are we studying landscape irrigation? Well, national irrigation research has shown that people with in-ground irrigation systems use on average 35% more water than those without in-ground systems. And research further suggests that irrigation amounts could probably be reduced by approximately 30% without any negative impact on the landscape plants. So we would like to see homeowners and people move away from the static, time-based control of the irrigation system and move toward a more conservation method. So certainly there are several ways to promote water conservation in the landscape, and I don't want to minimize these other pathways, but today I just want to concentrate on irrigation scheduling. So to find a solution to this problem, we began testing smart controllers. And smart controllers use some feedback mechanism by which to adjust the irrigation controller, usually based on one of these climatic or environmental conditions or soil moisture, or some combination of these factors, much like these factors I mentioned that control water use in a turfgrass. So we began doing on-site research many years ago around the state, basically to look at irrigation systems and also to assess this technology and see how well it would work into our communities. So our results from testing in the communities found that a group that we provided educational material to used less water than the control groups, and the control groups were allowed to irrigate as they naturally had done in the past. Further savings were also experienced by those that had installed one type of the smart irrigation controllers. And in fact, if you do the math, the average household that used a climate-based sensor saved about 23,000 gallons of water a year in their landscape. And those with a soil moisture sensor saved approximately 50,000 gallons of water per year. So the impact of this work is that these smart irrigation technology and control systems has shown to take about 14 to 14 months to get a return on investment. So these people not only are saving money over time, but also saving water. So we've taken that information and we've provided trainings on how to select and how to install these smart irrigation technologies. Here in this picture you see one of my colleagues demonstrating some of our on-site research at our research station, as well as some of our materials used in this training. So we've trained over 100 contractors very early on in an irrigation certification program, and hundreds more receive trainings throughout various conference and trade shows. So our work is helping North Carolina conserve water in the landscape.
For this particular project, one of the objectives was to not only develop the students' skills of applying statistical process control in a food manufacturing environment, but to also improve the students' environmental literacy so that when they go into industry, they'll identify problems that have sustainability-related issues and make an impact and make the world a better place. For this project, we collaborated with the folks at the CALS dairy processing plant on campus. And they're so good to work with, and their processing plant is a great opportunity to give the students some hands-on training that they wouldn't get otherwise. So we put the students into 3 groups, and each group had their own project, and the projects were different. We had one group working on water usage in the dairy processing plant, trying to reduce water usage. The second group was looking at the quality of that water as it went into the waste stream, so that it was a wastewater quality project. And then the third group was trying to reduce energy usage in the dairy processing plant. So all 3 of them connected together in a theme of sustainability. It was about a month into these projects when all 3 groups decided to focus on the crate washing machine in the plant because it had so much room for improvement. What they noticed was this crate washing machine was using so much excessive water, and not only that, but the cleaning chemicals that were being used to wash the crates were ending up in the drain. We were looking at chemical oxygen demand and biological oxygen demand, and the wastewater quality was just not good. And as all of this was going on, the energy usage, it was mostly the pump running the machine, was using so much excessive energy. So all 3 groups came together with their data, and it was a good story. As this project moved on and the story developed, some of the students stayed over spring break to collect their data, and then they saw an opportunity with the sustainability office on campus, which had their first request for proposals for a new grant program that they had. And so some of the students collaborated on a grant proposal in which they were proposing for funds to replace the crate washing machine with one that was much more sustainable. The students were not awarded that grant. It was a competitive year since it was the first year of that grant program. I think they had a good proposal, but at the end of the day, one of the outcomes was the folks at CALS have this data and this story to tell, and they've been working with industry to find a corporate partner who may be able to help us replace the crate washing machine. My dream outcome for this project is that it's just the beginning of us developing an understanding through scholarship and teaching and learning of how to take a group of students who may or may not understand the environmental issues that they'll face in their generation's lifetime. And so how can we take them and give them an experiential learning project in which they'll develop their environmental literacy skills so that as they go into industry, they'll take that with them and they'll take the initiative to start new projects to make that company that they're working at in a food manufacturing environment much more environmentally sustainable.